Hello. This project is mainly the use of semantic segmentation in Papanicolaou's mirror images, or shortly known as PAP's mirror images. And in this short video, I'll just walk you through what this project is actually doing and how it is presented. What is semantic segmentation? Semantic segmentation is nothing but classifying each pixel in an image to a label in such a way that the mask can be used to segment the information from the image. And the general outflow is in such a way that we have some images and then we do some architecture refinements and we find weights in such a way that the results will be labels for whatever images over here. A use case scenario which is commonly used in autonomous driving is semantic segmentation. So in this case, all this is the view of how a car or from the cockpit of a driver's seat, how the semantic segmentation would look like in real time. Okay, so coming to pap smear images, this pap smear image is used to identify cervical cancer, and this is a microscopic images. And the issue over here is that in this case, the nucleus is very prominent. Cytoplasm in most cases is not prominent at all. So if I just show you, this is the nucleus boundary, and typically this should be the cytoplasm boundary. And for going for semantic segmentation is it is difficult to segment it using conventional techniques. So you have conventional techniques to segment images, like you have region coding techniques like active contours, and then you have other thresholding techniques. And if you perform all those, the mask you'd be getting, this is the best possible version you can obtain using some conventional techniques. So you can clearly see that the crisp cytoplasm is left out totally. And one more important thing is that the data is also varying in size. This is a normal cell and this is a cancerous cell. So there is a typical variation in data which cannot be accommodated using conventional image processing techniques. And semantic segmentation is to rescue because it is a deep learning model which can accommodate for variance in data and also have high degree of computer vision knowledge, which it will learn through training. And the data used for this is from the pap smear benchmark dataset by Jan and Noru. And semantic segmentation, of course, has two networks in the architecture. One is to classify, another thing is to estimate. And the size of the image is restricted to 128 cross 128, depending upon the data set size. And these are some of the results which you can see, like over epochs. Like epochs is nothing but iterations in a training model in deep learning. So over iterations, the model has learned itself. Like epoch 0 is like the predefined weights initialized for such an architecture, and it has nothing to do with that. And over epochs, it has identified, and now at around 1350 or 1660 epochs, you can clearly see that the classification is proper, and the target class image, which is this label, is what we have created for training, and this is what the model has predicted. And to look into this into nuances, we can say that it has selected only the nucleus. It has left out some other artifacts which resemble the nucleus in the image. So that's how a semantic segmentation has some huge improvements in image computer vision in medical fields. This is a link to a GitHub repository which contains the source code and starting scripts for you to get started from scratch in such a project. Thanks.